Hello everyone, welcome back to the channel. So in today's video, we are going to solve another beginner friendly and uh, easy LeetCode problem number 367, valid and perfect square. So we will first understand the problem statement, then discuss the intuition, move towards the optimized solution, explain the code step by step, and finally talk about the immense space complexity. So without wasting any time, let's get started. So let's first read out the problem statement. So given a positive integer num, we can prove if num is a perfect square or false otherwise. A perfect square is an integer that is the square of an integer. In other words, it is the product of some integer with itself. You must not use any built-in library functions such as square root. So here we are giving a positive integer num and we need to check whether it is a perfect square or not. Now what is a perfect square? The number is called a perfect square if it can be written as 1 equals to 1 plus 1, 5 equals 2 cross 2 equals 4, 3 cross 3 equals 9, 4 cross 4 equals to 16 and 5 cross 5 equals to 25. So this is the perfect square between this shape 8, 10, 15 and not perfect square because there is no integer for square root exactly these numbers. The catch in this problem is we are not allowed to use any built-in functions with square root. So we can simply do square root of 9 and check. So here we need to find an estimate approach ourselves. So now just wait a second. So now here comes the important observation. Like we know like squares are sorted like 1, 4, 9, 16, 25, and 26. So since the values are increasing in sorted numbers, we can apply binary search here. So instead of checking every number one by one, we can reduce the search phase by search everything. So here is the idea. Like we take variable left equals to 1, right equals to 1, then clarify left plus right minus left by 2. So now check if mid square mid equals to none. Then yes, it is a perfect square. And if mid square mid into mid is less than the, that means answer lies on the right side. So left equals to mid plus one, and right equals to mid minus one. Then we will continue this until the six is ends. So now let's like first we will mm, write the code, then we will understand it. Okay, so long list proven and long line equals to now. Now line is less than equals to b. Okay, and long line equals to less plus right minus less plus 2. And line is equals to mid cap list. So, okay, if square equals to num, uh, we can prove also if square is equal to num, then we will give equals to num plus num, else I will write equal to num minus num. And if we will return, so now let's just Okay, this will connect to one before the we forgot the semicolon for the total. So as you can see, our solution is accepted. So now let's submit it and check if it is valid for all the possible test cases. So as you can see, our solution is accepted. So now let's understand this code step by step. So first we have initialize left equals to 1 and right equals to none. So we have used here long, so we can't get the issue of overflowing integer. So then we run a while loop until left is less than equals to right. Inside the loop, we calculate the middle element. We calculate the middle element using this formula, and then we are finding square equals to mid square mid. So now we are comparing if square is equals to num, then we are simply returning true. Else if square is less than num, then we are moving the left pointer to mid plus 1 or else right pointer to mid minus 1. And then continuing the loop till continuing the cycle till the loop ends. So here, if the loop ends and we still don't find the number, then we will simply return false. So one important thing here to notice is like why did we use 9 instead of 10? Because mid can overflow for large numbers. For example, if mid becomes larger, multiplication may exceed integer range. So to avoid overflow, we use line. This is a very important interview point. Now let's talk about complexity. So since we are using binary search and reducing the search space by half every time, space complex time complexity becomes order of log n, which is very efficient. In space complexity, uh, okay, so in space complexity, this is order one since we are using variables. So that was the complete explanation of lead code problem number 367 valid perfect square in CPP language. So I hope the problem statement, inclusion, binary search approach, the code explanation is are clear to you now. So if you found this video helpful, make sure to like the video, subscribe to the channel, and comment down which video problem you want. Thanks for watching, and I will see you in the next video.